my name is Morgan Chapman, and today I will be using the spectroscopy of simple molecules to solve a persistent health problem that is caused by an unknown substance on everyday foods. Now, these everyday foods are canned fruits and veggies. We're trying to find what is causing these symptoms in our consumers. They are reporting symptoms of weakness, dizziness, headache, nausea, vomiting, and blurred vision. We'd really like to put a stop to these symptoms, so we're trying to figure out what is causing them, what is the unknown substance. The objective of our experiment is to identify the unknown compound on our canned fruit using spectroscopic techniques. The first technique is infrared, or IR, which will help us determine the functional group of our unknown substance. Infrared technology is also used in tracking hurricanes. The other type of spectroscopic technique we will use is nuclear magnetic resonance, or NMR. NMR will help us determine the number of peaks and the ratio of areas of our unknown substance. This type of technology is also used in brain scans or MRIs. So first we were given 15 compounds and their Lewis structures. Now, and the IR and NMR spectra of our unknown substance on our canned fruit. We're trying to figure out which one of the 15 compounds given to us is the unknown compound on our fruit. Here is figure 1, which are the possible compounds and their Lewis structures of what our possible unknown could be. We have methanol, ethanol, T-butanol, T-propanol, acetone, ethyl formate, ethyl acetate, methyl acetate, 1,2-dichloroethane, 1,4-dichlorobutane, 1,2-dibromo, 2-methylpropane, and 2-chloropropane. We also have benzene, mesitylene, and paraxylene. Now, we'd like to find the functional groups of all 15 compounds to help us get down and figure out what our unknown substance is. So for example, let's take ethanol. This is a Lewis structure for ethanol. We see here that there is an oxygen to hydrogen bond and 5 carbon to hydrogen bonds. So from this, we can say that the functional groups are oxygen to hydrogen and carbon to hydrogen singly bonded. Using the same technique, we determine the functional groups of all other 15 compounds and put them into this data table. This is the IR spectroscopy, which will help us determine what our unknown substance is. We were also to find the NMR spectroscopy of our other 15 compounds by using graphs. This shows us the number of peaks and the ratio of areas. This will also help us find our unknown. Table 3 shows the IR absorption peaks and helps us find the functional groups of our unknown. Here is the IR graph of our unknown. So here we see that the broadest peak is right there, and that indicates an oxygen to hydrogen bond. We also see that another large peak indicates a carbon to hydrogen single bond. So from here, we can say that the functional group of our unknown, determined by the IR spectra, are oxygen to hydrogen and carbon to hydrogen singly bonded. Now, when we go back to our 15 compounds, we can eliminate most of them, and we're down to 4. Methanol, ethanol, T-butanol, and T-propanol. So now we must look at our NMR spectra of our unknown to determine what our unknown is. So we see here that the NMR graph shows 2 peaks. So from here, we can eliminate both ethanol and T-propanol because they have 3 peaks. So we are left with methanol and T-butanol. Now we go back to our NMR graph and look at the ratio. We see we have 2.95 to 1.0, or we could say that's 3 to 1. So then we go back to our data table and we see that T-butanol has a ratio of 9 to 1, where methanol has a ratio of 3 to 1. So we can eliminate T-butanol and we know that methanol is our unknown substance. So what does this mean? Methanol is a toxic chemical, whereas we do have some of it in our body, a lot of it is bad. It is in canned or bottled fruits, vegetables, and their juices, not the fruits and vegetables themselves, but in the packaging. And it is also used in chemical feedstock and aspartame. Aspartame is NutraSweet, Equal, and Diet Pop, any kind of those diet foods. And actually, every molecule of aspartame turns into a molecule of methanol, so it's very bad for your system. So in the future, by finding these results, we know to make new packaging to reduce the risk of methanol poisoning so that we have happier and healthier customers. And then here are my resources. I used the lab manual, ChemSpider for the Lewis structures, and also the methanol health effects to help me with the methanol poisoning.